Okay, the first type of problem is going to give you your boundaries. So you're going to have two functions, and you're going to have like boundary lines. X equals this, X equals this. All right, so you're definitely going to do integration. Don't do derivatives here. So we are going to integrate, meaning we're going to do this little guy. Lower bound 0, upper bound 4. The other thing you have to determine is which guy comes first. Remember, you're doing the difference between the two curves, the area between the two. The way you figure out which one you put first is you just pick a number and plug. I mean, honestly, if you don't have a graph, which this one is maybe obvious, but put in a 1. Like if I plug in a 1, I have 2 times the square root of 1. And for the other one, I have negative square root of 1. Which one's higher? Well, this guy, he's going to go first. So I'm going to say 2 square root of x minus negative square root of x dx. Simplify before you do your antiderivative. So I have 2 square root of x plus square root of x. That's the same thing as 3 square root of x. And by the way, square root of x is x to the 1/2. So when you're doing antiderivative, you may want to write it that way so that you can very easily do antiderivative. Remember, antiderivative is add 1, divide by the new. So I'm going to add 1. That's going to be x to the 3/2. And then I'm dividing by 3/2. So I'm multiplying by 2/3, which means I have 9/3, right? So the 3's will cancel. Something like that. Okay. And then we're going from 0 to 4. All right. Now remember, x to the 3/2 is just the square root of x cubed, right? So when you plug it in, that may be the way you want to look at it. Plug in a 4. The square root of 4 is 2. 2 cubed is 8. 8 times 2 is 16, and that is my answer. Because if you plug in a 0, it's basically 16 minus 0 is what you're going to get when you plug in your 4 and your 0. Second type like this could potentially be a trig, and likely is. So for trig, you're going to do exactly the same thing. It is going to go from your bottom, which in this case is negative pi over 6, to your top, which is positive pi over 6. You need to determine which one is which. I would just probably put like a 0 in there. So negative sine of 0, which is in between those, and 2 cosine of 0. Sine of 0 is just 0. Cosine of 0 is 1. So my cosine is actually larger here. So I am going to put the cosine first. 2 cosine of x minus a negative sine of x. So that's plus sine of x dx. Antiderivatives here. Hopefully you know your antiderivatives of your trig functions. Antiderivative of cosine is positive sine. Antiderivative of sine is negative cosine. And we're going from negative pi over 6 to a positive pi over 6. Then you're just plugging it in. So we have 2 sine of pi over 6 minus cosine of pi over 6. We're going to subtract 2 sine of negative pi over 6 minus the cosine of negative pi over 6. Pi over 6 is a 30-degree angle. Hopefully you know that. But the sine of a 30-degree angle is 1/2. So I have 2 times 1/2 minus the cosine of 30-degree angle is square root of 3 over 2. And then minus 2, the sine of negative 30-degree angle is actually negative 1/2. But the cosine of a negative 30-degree angle is still positive square root of 3 over 2. My cosine doesn't change there because it's in the fourth quadrant, positive x there.
Wait, so you don't take it the cosine?
You do. Sorry, I just rewrote it while I was talking. It's just positive square root of 3 over 2. This guy becomes just a 1. I'm going to get common denominators here. So it's 2 over 2, because that's minus the square root of 3 over 2. Plus, because it's minus a negative, 2 over 2. Plus, because it's minus a negative, square root of 3 over 2. Those cancel. this just becomes 1 plus 1. That's 2. So you'll notice here, I don't have any other boundaries. I just have the two functions. So my first step here looks a little bit different. For my first step, this one, I need to set them equal to each other. X squared minus 6x plus 6. Where does that equal negative x squared plus 8x minus 14? I'm going to move everything to one side and solve for where those equal. So I'm going to add my x squared over, subtract my 8x over, and add my 14 over. Factor out a 2 because this is equal to 0. So I have x squared minus 7x plus 10. Factors of 10 that add up to 7. So that's 5 and 2. So I have a 5 and a 2. So that's my upper and lower bound. X equals 5 and 2. Upper and lower bound. And then I'm going to do exactly the same thing like I did on the first page. So now I'm going to go from 2 to 5. I just have to determine which one gives me a higher number. So if I pick like a 3 and plug it in, you'll actually see that this function is above that function when you plug in something like a 3. You get negative 9 plus 24 minus 14, so you get a 1 there. Here you're going to get 9 minus 18 plus 6. You're going to get a negative number for that one. So this is the higher one. So we're going to say negative x squared plus 8x minus 14 minus, this is the entire group subtracted. I'm doing that because distribute that negative correctly. By the way, this will look just like what happens when you move them to one side. It just may change from positive to negative. So when I combine those, I actually get negative 2x squared plus 14x minus 20. It looks just like what I had up there. It's just negated because of the way I moved them across. And now I'm just doing basic antiderivative. Add 1, divide. So this is negative 2/3 x cubed plus 7x squared minus 20x. And I'm going from 2 to 5. This actually ends up being a lot smaller than it looks like it's going to be when you start. If you plug it in, 5 cubed, that's what, 125, so negative 2/53 plus 5 squared is 25 times 7 is like what, 175 over 1 minus 20 times 5, which is 100. I would make this, we'll go back to that, but anyway, subtract 2's. So we have 8, so negative 16/3 plus 28 minus 40. Simplify, this guy is 75. This guy is negative 12. Minus a negative, so that's 87. Minus the negative there, so I'm adding, so that's negative 2. That's reducible, so that's negative 78 minus 87, or plus 87 equals 9. This guy actually ends up being a huge fraction, but that's okay. For this one, I am again going to set them equal to each other, but when I do, I'm going to see that I have 3 points of intersection instead of just 2. We'll try this again. Negative x cubed. You know what? I may move everything to the other side. I want all positives here. Sorry. I'm going to say x cubed plus x squared minus 6x, better, equals 0. X, and we have x squared plus x minus 6 equals 0. That's going to factor to x plus 3, x minus 2. So you'll see that my x's now have 3. It can be -2, no, -3, 0, +2. And that's the order I'm going to put them in, right? So I'm going to set up 2 different guys here. I'm going to say from -3 to 0 and from 0 to 2. Right. So when I do this, I do have to figure out which is higher and lower. And it may be different depending on what happens. So from -3 to 0, this actually ends up being the higher one. If I were to put a -1 in there, this is going to be positive. This one is actually going to be a negative. So if in between this group here, it's going to look like this, -x minus this whole. All right. When I go to this one and plug in a 1, it actually switches places. So I have this group first. I have -x cubed minus x squared plus 5x minus that -x. So they're going to look exactly the same. They're just going to be negations of each other, the whole thing. When I simplify this first one here from -3 to 0, I'm going to get a positive, right? Negative, positive x cubed, a positive x squared, right? And a -6x. When I do this guy, it's just going to be exactly the same but opposite. A -x cubed, a -x squared, a positive 6x. So they're going to look identical. They're just going to be negations of each other. And then just plug it in and solve. So I'm going to take my antiderivative, plug my 0 and 3 in. Now, I do want to point out when 0 is your upper bound, pay attention. You can't just ignore him because it's going to be 0 minus whatever that answer is for -3, okay? He's actually going to change the sign of that -3 plug-in. It doesn't affect anything over here because over here you're subtracting 0. So that doesn't matter. But that first group, the 0 matters, and I see a lot of negation problems with that one. So do keep in mind that you are doing a 0 minus. And then when I do this, it's going to be, what, 1/4, x to the 4th, 1/3, x to the 3rd, minus 3, x squared, right? So we're plugging in a -3 to that. This is what, 81/4 plus, what, 27/3, so that's 9 minus 27. That's a -9. And then over here, let's do this. Let's maybe do the actual antiderivative here. Plus 3x squared. That would help. That would help when I plug in a 2. Yeah. All right, so let's try this one more time. That's 16, so that's -4. This is going to be, that's how we do it, -8/3, so that's going to be plus 12. Sorry. Yeah, it helps to actually do the antiderivative. Now that's going to make my life a little bit nicer. So this is 81/4. This we said was 144/4. That's negated there. This guy becomes 8/1 multiplied by 3, so that's 24/3. Subtract 8. So that's what, 16/3? 63/4. It's going to be positive. So that's negative. So this is going to be positive 63/4. Common denominator is 12. That makes sense. So this is going to be 189. I just felt like it was wrong. All right. So this is 2480. There we go. You can decimal form it if you want to. That's 253.
Can't reduce at all. That's
It's 253. Sorry, 253 over 40.
getting excited when you increase that. And it can't reduce at all.
This is 60.
That is,